This is the 6-1 to 6-3 review. Calculators are allowed, and it's number 10, the free response problem. So in this one, I've actually given you the picture for the region for which I want you to find areas and volumes. And if we read the whole problem, we can see that we're finding an area and that we want to rotate around a horizontal line, and then we want to build a solid with bases that are perpendicular to the x-axis. So I'm going to have the easiest time with all of this if I select to draw my slice vertically. So I'm going to draw one strip, and then I'm going to use it multiple times. Because I drew vertically, I need to label with x's. This top curve is the root curve, so that's x to the 1/4. And make sure that if you put that into your calculator, which we're going to need to do, that you raise your exponent and put that in parentheses. And then on the bottom, we'll have e to the -1/8 x. We're going to need this x intersection point here, and we need to know that we're going all the way out to 16. Oops, this one's the 16 too, sorry. And this one is e to the -2. Alright, so our job now is to find the area first. So the area is going to be the area of this strip, which is the length of that strip, which is the top y-coordinate minus the bottom y-coordinate, times the thickness dx, and then we need to accumulate from this x-coordinate of the intersection all the way to 16. So what we can do on this that will actually make the problem easier for us setup-wise is we can solve for this point and write down what it is. So this is xc, yc, and we can tell the graders of this problem up at the very beginning that xc is going to equal a number. So on my calculator, I have already put the two curves in. I have not adjusted the window, so let's go from -1 to 17 so that we can see the whole picture. And it looks like we need to go from -0.2 up to 2.2. I'm just going to try and duplicate this picture that I have here, so I'm using the same sort of window. If we graph it, we can see there's our fourth root curve. And then here will come our exponential curve, and we're interested in finding that intersection because we're going to use that x-coordinate in all of our setups. So F5 will go to that intersection, enter, enter, 0, and let's say 2. So I'm going to write down that xc, 0.703467742. Now remember, you cannot round that number and then use it in subsequent computations because it'll screw you up. So by labeling this as xc, yc, and writing down what xc equals, we can now use xc in all of our setups and we'll get full points. So on the home screen now, we're ready to compute this integral. And notice that I had x to the 1/4 in y1, and I had the exponential in y2. So I'm just going to use that repeatedly as y1 and y2 on my home screen. So if I want to compute this, I will do the integral of y1 of x minus y2 of x with respect to x from xc up to 16. Now notice what I have in my calculator is not what I have written on the paper. On the paper, I need to show that I know what that top curve is and I know what that bottom curve is, and I need to actually set up the integral because part of your points come from having that setup. The integrand needs to be correct. So I'm going to hit diamond enter, and I get an area that is 18.841 or 0.840, your choice. You just need to make sure you give me 3-digit accuracy. So now we're ready to do part B. Part B says find the volume of the solid generated when r is revolved about the line y equals 2. So looking up at this picture here, if I have y equals 2 as my axis of rotation, kind of drew that in the wrong place, then I'm going to need to label a point here so that I can find my big radius and my little radius. So this point here is going to be x. It's the same x coordinate as the 3 that or the 2 that I've already labeled, and the y coordinate is going to come from that y equals 2. So when I draw my sample slice, it's going to be a washer because I've gone perpendicular to what I'm rotating around. So down here in part B, I'm going to actually draw the picture of that washer so that I can label the parts and pieces that I need for my setup. So the thickness of that washer is a dx. The big radius is going to come from, now if we remember on that picture, we had our red strip and then we had our blue axis. So the big radius is going to be from the axis all the way to the edge. So looking up at this graph here, it's going to be the top blue y coordinate minus the bottom red y coordinate. So it'll be a 2 minus that exponential. So my big radius is 2 minus that e to the negative 1/8 x. And then my little radius, this distance, is going to be from the blue y coordinate to this y coordinate. So that's going to be 2 minus the 4th root of x. So down here I can write that my little radius is 2 minus that 4th root of x. So if I set up my integral now, my volume will be a pi times the integral of my big radius squared minus my little radius squared times the thickness dx, and again my limits are going to come from dragging that strip as far left and as far right as possible in the region. So the leftmost bound is going to be xc and the rightmost bound will be the 16. So I can write xc to 16. So we've got all our setup points now. We've got our integrand, we've got our limits. We just get one more point for the answer. So on the home screen now, remember we're going to have 2 minus that y2 squared minus 2 minus that y1 squared, and we'll go from xc to 16. So I'm going to have to cover that up so that you can see the calculator, and then we'll go back up. So here I'm going to change my integrand, and I'm going to do 2 minus y2 of x. That's going to be squared. Then I'm going to subtract the 2 minus y1 of x squared. And then I'm going to tell it I want to integrate with respect to x from xc all the way up to 16. Done. We need to have the pi out in front. So second pi, 114.263. Okay, last part says the region R is the base of a solid and each cross-section perpendicular to the x-axis is a rectangle whose height is 3 times the length of its base. So we've got that same red strip that we had up above, except now instead of rotating it or just finding its regular area, we are going to have the base, and then we're going to build a big rectangle coming up out of the board. So we're going to tip it over, and we're going to see that this length was that top x coordinate, or excuse me, the top y coordinate minus the bottom y coordinate. And now the height of that rectangle is going to be 3 of those. And the thickness is still going to be dx. So if I want the volume of that, the volume will be the base times the height times the thickness. So we'll have a 3 of those x to the 1/4 minus e to the negative 1/8 x squared times the thickness, and we again will accumulate from xc to 16, 80.697. And we're done.